is a little bit noisy today, so we're going to try to keep the microphone up here. Today we're going to be talking about some new animals. Before we get started, Headwater Science Center, we are open 7 days a week. 9:30 to 5, Monday through Saturday. Sunday, we're open 1 to 5. And then also, coming up in April, we have another prehistoric painting night. So that is going to be another night where kids can come in and print up a prehistoric animal and paint it. And this next month, it's going to be run by a Bemidji State University capstone student. So please feel free to sign up as early as you can. We do take walk-ins if there are available spots, but if the entire sign-up sheet is filled out, we cannot take any more walk-ins. We have a limited number of animals made. All right, so today we are going to be talking about our first little live stream on marine reptiles, starting with the Plesiosaurs and the Pliosaurs, a group of marine reptiles that's pretty famous. So these animals lived from 210 to around 66 million years ago. So they lived from the late Triassic all the way towards the end of the Cretaceous in some way. And we're going to go over really quick where they sit as far as animals, and then some of the things that made them rather unique. And then also go over some of the adaptations they had for being marine animals. We've talked about whales recently, and they actually have a lot of very specialized adaptations, and so did these animals. So the first thing is, obviously, they are kingdom Animalia, phylum Chordata, meaning they are animals that have a backbone. Next, they are Reptilia. The superorder, we're going to have a lot more things. This is going to be a bit more in-depth. They are Sauropterygia. Sauropterygia? My Latin is terrible, as we've learned. They are in the clade Pistosauria. They're in the order Plesiosauria, and we are today going to talk about the subgroup Neoplesiosaur, which has two superfamilies, and those would be the Plesiosaurs and the Pliosaurs. So, what is the difference between a Plesiosaur and a Pliosaur? We're probably all far more familiar with Plesiosaurs. Plesiosaurs are those marine reptiles with the very long necks, very small heads. They generally were smaller, although some of them could be quite large, where the Pliosaurs had very large heads, short necks, large bodies, and tended to be quite big. The largest Pliosaur was around 35 feet long, and they're still trying to estimate the weight on it, whereas the longest Plesiosaurs, while being more than 30 feet, would have been a lot lighter. Now, they did also have a difference in diet. Plesiosaurs generally ate smaller prey, where Pliosaurs fed on a broader range of diet, including some larger things. And they are a group of animals called pentastudines, which actually means they're closer to turtles and archosaurs than they are to reptiles like snakes and lizards. That's not going to be the case for all the marine reptiles we'll cover while we're talking about marine reptiles in these live streams. So, these animals have a worldwide oceanic distribution. Their diet includes fish, marine invertebrates, and even other marine reptiles. And then they have a lot of fun traits. They are fully aquatic. These animals would have had little to no mobility on land. It was initially thought when their fossils were found that much like seals, the smaller plesiosaurs could haul themselves up onto land, but with more careful analysis of their flippers, their legs, they realized they really couldn't support any weight like that. They weren't quite as mobile on land. They would have been lucky to have the mobility that a sea turtle has on land, which is not a lot. If any of you have seen a sea turtle, they can kind of haul themselves up, but they're not graceful. Another kind of cool thing about them is a fossil was found that was of a adult plesiosaur and a plesiosaur mid-birth. They were live-bearing young, so meaning that they gave birth to pseudo-live young. And generally, a commonality between plesiosaurs and pliosaurs is that they had these large, flat bodies. They had 4 flippers, 2 front ones, 2 back ones. They also had slightly fluked tails, which is a recent discovery with a skin impression. And another really cool thing is they use what we call gastroliths to digest their food. They would swallow stones that they would use in their stomachs to grind up what they would then eat. And another thing about them is that, much like whales, they are what we call secondarily aquatic. Secondarily aquatic means it is an animal that has a fully terrestrial ancestor that has adapted to again be fully aquatic. Whales are probably the most common example, but also manatees are secondarily aquatic, as well as pretty much all of the marine reptiles we will cover. So, another thing is you'll notice that I didn't actually draw an animal on the board today, and that's because I actually got to make these models. I was ahead of the game on this. So, if you want to zoom in on this guy first, which is that WT thing on the camera. And it goes side to side. So this, yep, so zoom in. Yeah, that's all the thing. So this is the Pliosaur model. So we can zoom in even further. So you'll see, has this very large head, very short neck. He's got the flat body. He's got that little fluke on his tail. And he's got those four flipper limbs. And then we have the Plesiosaur. I'm going to get a little bit closer because he's a bit smaller. Who has those four limbs, but he's got that long neck and that relatively small head, and also has that fluked tail. And just to show the size comparison, these two models are made to scale for the species they're supposed to be. You can see there's a big size difference. So pliosaurs were a group of animals that we do know fed on other marine reptiles, sometimes even other plesiosaurs and pliosaurs. Whereas the plesiosaurs would have been eating mostly fish and small marine invertebrates. So a thing you'll notice about the model for the pliosaur is it is gray on the top and white on the bottom, much like many marine mammals today, some whales, and many sharks. And that is what we call counter shading, which is where an animal is dark on top and light on bottom. And that is a specific way to camouflage in not just water, but a lot of times in marine habitat, where when there's light coming from above the animal, it will illuminate the gray or the darker half of the animal on the top half. And since there's not light falling on the bottom half, that will appear darker, making the animal look more of a uniform color in the water and kind of blending it into the background, meaning these animals could sneak up on other things. Great white sharks are a great modern example of counter shading. They use that to sneak up on their prey all the time. And so we're going to talk about the plesiosaurs and the pliosaurs. So the plesiosaurs were actually able to make it all the way to 65 million years ago, when not only the dinosaurs went extinct, but many other of the large animals of the time went extinct. Whereas the pliosaurs went extinct about 89.3 million years ago. And there is a reason for that. Around that time, another group of marine reptiles became far more prominent in the ecosystem. We are going to cover those for the next live stream. But they were outcompeted, and this is again the rule of competitive exclusion. When two animals are doing roughly the same thing in an ecosystem, generally one of them is going to do it better, and the other either has to go do something else or may go extinct. But yeah, so I've drawn kind of a crude sort of illustration of counter shading. We don't need to zoom in on that. That's not my best work. But what? No, zoom in. But generally, plesiosaurs and pliosaurs are probably some of the most well-known animals. So the thing about plesiosaurs is probably everyone's thinking of the Loch Ness Monster, but that's pretty unlikely. The other thing about plesiosaurs, how we've thought about how they use their necks has changed over time. It used to be thought their necks were quite flexible and mobile, like sort of like a snake's body. Recent examination has shown they were rather stiff. They had some movement at the base where they could really swing the neck around like that in a straight line, but they weren't really able to wind that neck around. A lot of people think that long neck may have been used to keep the main body of the animal further away from the head, meaning it could get that smaller head in among a shoal of fish without alarming them of the presence of the actual size of the animal, which is a pretty good hypothesis, actually. but we still don't fully understand it. Another kind of cool thing about these animals is there really aren't anything like them around today in their method of swimming. It's thought that they used basically a two-stroke swimming method where the front legs would what's the good word for that? Would do a stroke in the water, and then the back legs would then follow it up, allowing really good maneuverability and speed and sustained movement. There are no marine animals today that use this proposed method. It's something that would have really only been possible with the plesiosaur and pliosaur anatomy. And then pliosaurs, again, these were large, successful predators. They managed to be kind of the top of the ocean ecosystem for millions of years. It took a very, very efficient type of animal to outcompete them. And then these animals show up all the time in media and culture. Again, plesiosaurs have kind of become synonymous, unfortunately, with the Loch Ness Monster. They show up in prehistoric movies all the time. Pliosaurs. If anyone watched Walking with Dinosaurs as a kid, Leopleurodon is an amazing example of a pliosaur. They are, again, rather unique animals. They're visually striking. And there's something that, again, we don't really have a great equivalent to in the modern day oceans. Maybe toothed whales is the closest. Other than that, Nick, do you have any questions?
I don't really have any questions, but I just think that the Pliosaur, it kind of looks like a Mosasaurus.
They do look very similar, and actually, Nick just kind of totally hit on the animals that a lot of people think outcompeted pliosaurs were mosasaurs, and that's why we're covering them next.
I'm ahead of the game.
Yeah. Well, that's all for today, everybody. Thank you for tuning in. We're getting close to spring, and remember, Prehistoric Painting Night's coming up on April 22nd. Call us here at the Science Center or email if you find the posters around town. And please sign up ahead of time to make sure that you get a spot so you can paint your animal. And when we get closer to the date, we will review